Okay, thanks for joining. It's late after lunch, so hope I'm not boring you. This talk is about Open Telemetry and your tests. And this talk is, well, we would like to continue with the message that my friends from Elastic did yesterday. I don't know if you attended the talk about Open Telemetry and the CI/CD process, observing the CI/CD process from my folks. And they explained it, well, the continuous delivery process, how to observe it. And I would like to focus on testing, because automated tests sometimes provides a lot of insights that are there and nobody's looking at them. Well, about me, I've been more than 20 years, or around 20 years in this industry with different roles. So I've been moving from one place of the other in the delivery process, from IT support, consultancy, support, test automation, maintaining open source projects. Well, just to give a little bit of context, this is my Twitter account, and well, everywhere you can find me there on the internet. So what I'm going to see today. First, I want to start with the journey in our CI/CD in observability. Then I will focus more on testing. And to finish this presentation, I will share the report that we would like to have. I would like to share with you that we are in a journey, that we are at this moment here. We are collecting data, and we are in a process of thinking what are the metrics and the reports that we would like to have. So sharing here with you what we like, maybe provide us own insights. So all the feedback that you can provide us is very useful. So in this journey, we are creating tools. We are trying to identify metrics and weight reports that we would like to have. All the tools that we are creating are open source, and well, I will share with you there. So the first one is, what is observability? Because we are talking about Open Telemetry, observability. There are other talks that we have mentioned it, but the the vast majority of definitions out there says that observability is the collection of data in production systems, right? So you get data that allows you to answer questions beforehand you need them. And it usually comes with tools for exploration and visualization of this data, these insights, so you are able to analyze, react, and respond on expected and unexpected behaviors. Because we all know all the expected things, but what happens with the unexpected things that happen in production? Traditionally, there are three pillars: application performance monitoring, logs, and metrics. And this is the data that we would like to collect in general in observability. So the title of the talk is about Open Telemetry. So what is Open Telemetry? Directly from the website, Open Telemetry is a collection of vendor-neutral tools, APIs, and SDKs that allows you to instrument, generate, collect, and export the telemetry data. Sorry. And it helps you to analyze your software performance and behaviors. What are the benefits of using Open Telemetry? Well, it's open source, so you can contribute, you can open issues, you can consume what the projects that they use. And for me, the most important thing is that you are able to instrument your application once, and depending on the vendor or the backend, they call backends, that you are using, you can replace and change whenever you need. You could use Elasticsearch, for example. You could use Zipkin. You could use Prometheus. Depending on the backend that you're interested in, you replace it and everything works. So, sorry. Okay, let's move in the things that, as a team, it was there, but we work in the engineering productivity team. So we are supporting other teams to do their job. So what do we want to discover? The first one is about the CI/CD process. We own or we run production services for CI/CD. In this particular case, Jenkins is our tool for that. And we're interested in detecting what are the bottlenecks. As owners of the system, where the time is spent. Do we have bugs in the plugins that we use? Are there leaks in in the logs, for example, these kind of things are things that we are interested in. And the second major problem that we're interested in is about notification and ownership. We have detected a process gap between the test failures and the owners of the ownership of those failing tests by product teams. And this is especially pronounced when those tests span multiple teams or multiple projects. So who is going to resolve these tests? Okay, so our goals as a teams are, hey, let's notify the right teams, because probably we are adding a lot of noise in Slack or by email. Well, let's notify the right people. We also want to detect flakiness. This is a topic that has been around in many of the talks here, the flakiness detection. Also about ownership of the test failures, as I mentioned, detecting who is or which team is the responsible of resolving a test failure. And finally, improving the usability of the test failures. And especially because we are using Jenkins, sometimes the Jenkins UI is not that easy to digest when you are looking for test results, test logs, etc. Okay, so, sorry. In this journey, what open source tools are we using? And I say open source because everything that we are using is open source. So we would like the other teams to use them. So if you are interested in, please reach us later. So we are happy to share with you how to do it. My folks, Ivan and Victor, gave this talk yesterday. So they did a really interesting demo. So what I'm going to list is in the demo. But, well, just a simple highlight. We have contributed to the Maven community, the Open Telemetry plugin. Well, Open Telemetry community, sorry, the Maven plugin, which allows you to, well, simply adding the extension in your POM file and exporting the environmental variables where the Open Telemetry collector is, here, the variable. You are able to see the traces for your build, and you can understand, well, what could be possible bottlenecks in the build of Maven, a Maven project. Another project that we have contributed in this case to the Ansible community is the Ansible Open Telemetry plugin, which is able to add distributed traces for any Ansible task. Well, it's in the community there, and I recommend you this link, this blog entry, in the Elastic blogs about how to use it in your infrastructure when deploying things with Ansible. Super easy to use. You have an Ansible configuration file, you add the callback, you define your playbook, and that's all. You have your distributed traces for the Ansible. Another tool is the Hotel CLI. This is not ours. This is from Equinix Labs, and it's able to, well, you can instrument shell scripts so that it will send traces for these shell scripts. Sorry. Another project, and this is one that we have contributed to the Python ecosystem, is the Pytest Open Telemetry plugin. So if you are running, your project is written in Python, and you use Pytest as a test runner, simply the distributed tests will be there for your test. Simply requirements.txt file with the dependencies, you add it there, you expose the environment variables, where the collector is, and you have your test in a nice view with traces and spans. And finally, the Jenkins Open Telemetry plugin. Our team have created this plugin, and it's in the Jenkins organization, which allows you to create traces from the built-in steps in Jenkins. So you will be able to see all what's happening in a Jenkins pipeline, see the traces for that. It also collects metrics about the CPU, work allocation, memory, etc. And with a simple pipeline, you will be able to identify what are the stages in that build, what steps has been executed. And if you are using distributed traces, you will be able to see the different traces, all of them connected. For example, this is the attributes that we are gathering and collecting and exposing them, in this case, in the Elastic observability solution. But After Ariane 5, a lot of explosion of interest in testing. Let's talk about tests. I guess that everybody in this room is writing tests, right? Yes? In which languages? Java, Go, Python. Which one? Well, multiples. Java, Go, Python, Ruby. We mentioned Pytest, and with the plugin that we created for distributed traces in Python. But there are multiple teams with multiple languages, multiple test reporters, test runners, sorry. And especially in observability, we have teams working with Java, working with Go, working with .NET, working with Node.js, etc. So a lot of frameworks, a lot of test runners. Cucumber, it could be also possible to do it. So we found an issue here. Should we contribute the same philosophy, the same reporter to like the Python one to all these communities? We don't have resources to do that at this moment. We are doing a best effort in trying to resolve our own projects or our own problems. So hey, but we discovered a commonality here. In all of those actors, there was one actor that was common to everybody, to all of them. And this is XML. XML was a de facto standard in the past for process-to-process communication. What happened? What had to do with the other test runners? The majority of the test runners are able to export to XML, to jUnit format, right? And this is, well, Jenkins, for example, is able to consume it in a native manner. So let's try, how can we get with this XML? Well, jUnit has a well-documented, a well-known schema, XSD. So we know the definition of the schema. The majority of the test runners support it. And with this simple file, which is an XML file, we can abstract from the process of running the test, the CI/CD platform, and we can abstract from the programming language. So if we have multiple teams, we could do it for all of them in one shot. So parsing this jUnit XML file, we will be able to send traces and collect metrics, like the number of tests that passed, were skipped, count, and create these graphics that I share with Python for all of them. This is what's happening in your CI/CD server. You run your tests, hopefully in Git. You have failures. You export to an XML file, and you have a process that parses that XML file, reads the Git context, and for me this is important, and finally send the traces and metrics. Why do I want to highlight the Git context? Because when we are submitting, for example, a change request, a merge request, a pull request, we have a lot of information from that submission. We can get who is the author, the files that were modified, how many lines were added, how many lines were deleted. Useful information. We can collect that information from a pull request and attach this information to a test execution. And if it failed, this failure, whenever we modify this file, causes that this test is broken. We can correlate things. So we are trying to add information about the context, the Git context, to look for this correlation. Probably we get to the closed alley, but we are getting this information to identify and get insights. So how can we process this test? Remember the Jenkins Open Telemetry plugin? We have an internal version of the project that is not released yet, is not contributed, but leverages the jUnit plugin in Jenkins, because there are extension points in that plugin that allow you to execute code after each test is executed. So we created an Open Telemetry data publisher, which is the name of the extension point. So whenever Jenkins is parsing the jUnit file, it will send traces, metrics, etc. for that test execution. You have the link for the documentation. Sorry. And this will be how it goes. In white, it will be a traditional jUnit step in a Jenkins pipeline. If you add the data publisher, you will have this for free. So you just change your pipelines with one line of code, and you have it. This is not merged yet. We want to go very carefully with that. We need to explore it internally first, but this would be what we like to do it. And that will be the result. This is a Jenkins execution with all the distributed traces, the pipelines. Here, you can see this icon. This is the Elastic UI, but it could be the same for Jagger or Zipkin or whatever. It means that it's a separate trace. Here we have the test result is another trace that is under the jUnit step in Jenkins. But what happened with other CI/CD platforms? You could use Jenkins, you could use Travis, you could use Argo CD or TeamCity, whatever. Sorry, whatever CI/CD platform that you are using. We started with a CLI written in Go to do that. Leveraging the Open Telemetry Go SDK, we try to achieve the same that we did with Jenkins. Parsing an XML file, which there are libraries that provides the structure for the XML, the XSD schema for jUnit. In this process, we read the SCM context of where this code is executed, a pull request, a merge commit, a release, etc. Get this information, and we would like to run this in multiple platforms. That's why we chose Go. So we are able to run this in Linux, Darwin, or Windows. So we are abstracting also from the CI/CD platform. This is the URL of the project, so contributions are accepted. That will be it. We pass as an input the file, and it will automatically send traces from that execution. You are able to define what is the trace name, the service version, the service name with flags. Or if you don't pass it, it will try to infer it from the repository. And I have a demo. It's recorded, so no live coding. So yes, it's in the repository, the demo. So you can follow. You don't follow it, it's there. It's starting a Docker Compose file with Open Telemetry collector and Jagger. And those are the environment variables that you need to export. This is the content of the XML file representing a jUnit execution. There are no services in Jagger right now because it's completely empty. Yeah, we are going to execute the code in the jUnit. Sorry for the size of the terminal, but it was recorded a few days ago. I didn't consider this was that big. It's passing the flags to identify that this is a Go project, and the second one is a JavaScript project. So we will see two services now. One for the Golang project and one for the JavaScript project. And this Golang project, if we find the traces, we will see the distributed traces representing the XML execution with all the context, the SCM context that we added. In these tags, we are XML repository, SCM, the type of the repository, the test suite name, etc. And the same for the JavaScript project. This is what I copied from the internet, and this is Casper.js project with a huge number of tests, the version that we pass, and all the metadata, the attributes to the spans and the traces are there. I think the demo is done. So we're talking about attributes that we're using. What name conventions are we following? First one, we would like to define two types of attributes. The first one is related to the SCM, specifically for Git, and the second part is about the test reports themselves. For Git, for SCM, like the authors in an array of email addresses, the name of the branch, the committers as an array of emails, the Git provider, or the type of the SCM could be Git, it could be SVN, etc. And the SCM type and the URL of the repository. This could be extended, of course, because it's in the library. If you contributed a unit more, we can get to an agreement. For Git, something that is specific for Git, the clone depth, it's a shallow clone, it's not a shallow clone, how many files were modified, how many lines were added, things like that can be added. This is the information that is extracted from the repository when the code is executed. And about the test reports, or the attributes for the tests themselves, we define this simple structure. We have a test execution that contains multiple test suites, and each test suite contains multiple test cases. It's the XSD of the XML report. Well, we are getting the attributes, and we are passing downstream all of the attributes. For a test suite, we collect metrics, like the number of skip, pass, fail tests, etc. For each test suite, we capture different attributes, and for each test case, we capture different attributes for the test case. And we are passing down the attributes from top to the bottom, and later I will go back to this. Example of the test results is basically the XML definition, the schema definition for jUnit. So it's a direct mapping, and we chose test as the initial, the namespace for that. And we are here now. This is at this moment we are at this point of the journey. Where we are defining how do we want to present this information. We are collecting data, and well, let's figure out with this amount of data what do we want. For sure, we have two reports that we are interested in related to the ownership, which is the first one. Well, everybody's interested in this, flakiness analyzer. We are able to collect information. We could define different algorithms to calculate the flakiness. The very basic one is in this time window, number of executions versus number of failures, and well, it would be very basic algorithm. We would like to provide support for bringing your own analyzer or algorithm, so it's possible in a future to contribute different algorithms and choose it depending on some configuration. The second one, or the second report that we are interested in selecting the owners of a test failure. So based on the history of a failure, well, inspect the Git attributes about authors, committers, etc., and try to identify who could be the closer to resolve or to track the execution. Also about the failures, which files are more likely to cause a test error, for example, or which files are closer to this test failure. And finally, this is the next steps that we would like, to continue with. I talk about attributes that are passed downstream. We need to check with the functional teams in Elastic, for example, that are writing the observability solution for APM, for example, about what is the best strategy to store the attributes. Should be stored at the top level, should be stored everywhere, because sometimes the query could be slower. And well, what is the most efficient strategy to store the attributes? The second concern that we have is about semantic conventions. We are we selected those attributes because we thought that makes sense, but there are open telemetry schemas. Should we stand for them? In this talk, in this conference, the CD events fork is also a thing. So should we stand for the CD events? Elastic has its own Elastic Common Schema. Should we adhere to that schema? We are following the own for one reason. We wanted to do it we wanted to create an MVP and start with something, because if we wanted to align with all the communities, maybe it could take that long. But we are open to start any conversation to stand to any of the schemas, because standardization, I think, or we think, is important. The second, or another concern is merging the data publisher with the Jenkins Open plugin, so everybody with a plugin configured will be able to get the benefit of this Open Telemetry for the test reports. Again, defining better reports. So we are not a testing team, so probably with the help of other more close to QA teams, we will be able to understand what they need or what other teams need. And finally, we would like to have a full integration with GitHub. Remember the CLI, the jUnit 2 OTLP? Developers are in GitHub. So they work there. They don't want to switch context to another tool. So probably we need more integration with GitHub, probably creating a GitHub action that allows to run this code there, and probably submitting back the results of the flag analyzer, as an example, to GitHub back. So in the pull request summary, share this information. And I think that's oh, sorry. That is all what I have. So thank you. If you have any question here, there, in the lobby, bars, rooftop bars, I'm open to it. Ivan.
My question is, you're using tracing, and I wonder if you have ever had any issues with sampling.
With, sorry?
Sampling, like you're not sending whatever player you're using as a PLP, right? Receiving your trace, it might actually drop a bunch of those. Have you actually experienced where like dropping some of those samples of tracing error, or there's also, you're talking about metrics at the end of the day, but there is scans. Do you have anything that converts the scans into actual metrics you're saying Open Telemetry?
Yeah, not yet, because, well, we are in an early stage, but I understand the problem, and I think in this case, the observability solution, and I'm talking for observability for Elastic, but I'm pretty sure that other products do the same. I think it's covered. So we have an entity which is the APM server that is able to massage the information, and, well, this rating you can configure, and it will send it in batches not to lose information, etc. So if that's your concern, in the Elastic Stack, that will be covered by the pieces that the Elastic Stack are. But I'm pretty sure that other vendors will resolve this problem.
So test data sets may be enormous. Have you seen any problems with data volume causing either presentation, visualization, or data collection issues?
You mean once we send them back to the send them to the backend? Yes, yes. For the collection side, the tool, the plugin, or the CLI, we need to stress test the process. So we are not there yet, but I understand that, and I think it could be really, really important to verify that huge amounts of data, be in the XML file or in the number of test results, should be, well, batched or to concurrently executed. So try to optimize the process. Right now it's serial. If you see the code, maybe you can laugh at it, say, hey, let's send a pull request and improve this. And on the other side, about the storage layer, in this case, I'm pretty sure that the backend are resolving this problem almost for free. I can talk about it from Elasticsearch standpoint, and it's one of the benefits of using Elasticsearch. So huge amount of data. So I think that will be resolved.
You mentioned a little bit about finding owner for a particular test failure. Are you able to identify the particular file and test within using some of the Git data, or is that not part of it?
It's part of our journey. We would like to get to that point, to identify which files are causing which failures. I think we can get there if we run a lot of builds and we collect the information from those builds. If we are able to identify that one file is always in the chain set, when this test fails, we can create correlation. But we need to measure. We need to get that information first.
From jUnit files, do you typically get
Yes.
one of the things is like your test names, like for instance, especially thinking about Cypress, right? Like their test names are very like they're words and sentences as opposed to like test names. How do you find the actual test associated with that?
Well, it depends of the reporter or the conversion from Cypress to XUnit report. If the processor that in the NPM processor that is converting the Cypress test to XUnit is adding the path, we are reading what is in the XML file.
So you're relying on the jUnit.
Yes, yes, yes. For us, is the source of truth is the jUnit file. No more questions? Thank you very much.